Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Ming Jun. Today, we will study Chapter 3, PLC Program Controlled Punching on the Training Bench. Introduction to PLC200 Smart Programming. With the development of industrial automation, PLCs have been playing a crucial role across various fields. The PLC200 Smart we are using is a powerful and widely applied programmable logic controller. By learning to program it, we can gain a better grasp of core industrial control technologies, laying a solid foundation for future work or further study in related areas. We will explore this topic from the following parts. One. Installation of PLC programming software. To install the PLC programming software, we must first complete the hardware connection. A PC PPI cable is required to establish communication between the personal computer, PC, and the PLC. Connect one end of the cable to the PC's interface and the other end to the corresponding port on the PLC. Software installation. Before installing the software, close all running applications on the computer, including the Microsoft Office toolbar, to prevent software conflicts or installation failure. Also, ensure that the communications cable between the PC and the CPU is properly connected. Next, double-click the Step 7 Installation Program Setup, EXE, and the system will automatically launch the installation wizard. Follow the wizard step by step to complete the software installation process. We can choose the default subdirectory as the installation path, or click the Browse button to select or create a new subdirectory in the pop-up dialog box based on our needs. During installation, we will be prompted to configure the PG-PC interface, which is essential for communication between the PG-PC and the PLC. After installation, we can modify the settings of the PG-PC interface anytime via the Somatic Program package or through the Set PG-PC Interface option in the control panel. Of course, if we prefer not to configure it during installation, we can click Cancel to skip this step and configure it later. 2. Establishing communication with the S7200 CPU. After we install the software, the next step is to establish communication with the S7200 CPU. The PC PPI cable includes a communication module in the middle, which is equipped with a baud rate selector switch on the outside. This switch provides 5 PPI-compliant baud rate options: 1.2 kilobits, 2.4 kilobits, 9.6 kilobits, 19.2 kilobits, and 38.4 kilobits. The system default value is 9.6 kilobits per second. The baud rate selector switch, DIP switch, on the PC PPI cable must match the communication baud rate configured in the software system. There are 5 switch positions on the DIP switch. Switches 1, 2, and 3 are used to set the baud rate, while switches 4 and 5 are for setting the communication mode. For the default communication speed of 9,600 bits per second, switches 1, 2, and 3 should be set to 010. If a modem is not being used, both switches 4 and 5 should be set to 0. 3. Components of the PLC programming software window. Next, let's get familiar with the components of the PLC programming software window. 1. Main interface. Upon launching Step 7, Micro Win, the first thing we see is the main interface. This interface includes various menus, toolbars, and a workspace area. It serves as the main platform for programming operations. 2. Main menu. 1. File. This menu includes commands such as New, Open, Close, Save, Save As, import, export, upload, download, page setup, print, preview, and exit. 2. Edit. The Edit menu contains options like undo, cut, copy, paste, select all, insert, delete, find and replace, and go to. 3. View. This menu allows us to customize the development environment of the programming software. For example, we can open or close auxiliary windows like the guide window and the command toolbar buttons to suit our preferences. It also allows us to perform all operations in the guide window, choose different program editors, LAD, STL, or FBD, and set editor styles such as fonts and command box sizes. In addition, the symbol table view menu can be used to configure parameters such as data block, system block, status chart, cross-reference, and communications. We can also choose whether to display comments, network comments, the navigation bar, command tree, and output window. 4. PLC. This menu is mainly used for operations during connection with PLC. 5. Debug. This menu is an important tool used during online debugging. It includes functions such as single scan, multiple scans, program status, and trigger-based pause, and allows simulation of execution conditions through program status controls, e.g., read, force, and cancel all forces. 6. Tools. This menu provides access to complex instruction wizards such as PID, NETW, and HSC instructions. 7. Windows. This menu helps us manage and operate various windows in the software. 8. Help. If we encounter issues or difficulties while using the programming software, the Help menu provides relevant help tips. 3. Toolbar. 1. Standard toolbar. The standard toolbar contains commonly used operation buttons, such as New, Open, Save, Print, Cut, Copy, Paste, Undo, and Redo. 2. Debug toolbar. The debug toolbar is specifically used during program debugging. It includes buttons such as Start Debugging, Pause Debugging, Stop Debugging, Step Execution, and View Variables. 3. Common toolbar. The Common toolbar provides access to frequently used programming tools and commands, such as contacts, coils, timers, and counters. 4. LAD command toolbar. LAD stands for Ladder Diagram Programming Language. The LAD command toolbar includes buttons for various ladder diagram commands, such as normally open contacts, normally closed contacts, coils, timers, counters, and comparison commands. 4. Navigation bar. The navigation bar is an important tool that helps manage and navigate the project. It consists of the following main sections. 1. Program block. It consists of the executable program code and comments, including the main program, OB1, optional subprograms, SBR0, and interrupt routines, INT0. We can create or modify the program block and write our own program code by using the new or open commands from the File menu. 2. Symbol table. It is a highly useful tool that allows us to use symbols in place of direct addresses for programming. By establishing a mapping between custom symbols and direct addresses in the symbol table, along with associated comments, we can use more meaningful symbols for programming elements. This not only enhances the readability of the program and makes it easier to understand and maintain, but also ensures that once the program is compiled and downloaded to the programmable controller, all symbolic addresses are automatically converted into absolute addresses. The information in the symbol table will not be downloaded to the controller and does not occupy the controller's memory space. 3. Status chart. After downloading the program to the PLC, we can use the status chart to monitor the program's execution. In the status chart, we can add variable addresses and specify their data formats. This allows us to observe the real-time values and states of these variables during online debugging. 4. Data block. It is mainly used to assign or modify initial values for variable registers, and we can also add explanatory comments as needed. 5. System block. It is primarily used for system configuration. Here, we can perform a range of operations such as setting digital or analog input filters, configuring the pulse capture, defining the output table, setting memory retention ranges, configuring passwords, and adjusting the communications parameter. 6. Cross-reference. The cross-reference table lists the locations, POU, network, or line, of each operand used in the program, along with the command statements where these operands are referenced. With this table, we can clearly see how each operand is used within the program, including usage frequency and specific locations. 7. Communications. This section is mainly used to establish the connection between the computer and the PLC, and to set or modify the communications parameter. This feature ensures stable and reliable data transmission between the computer and the PLC, enabling programming, debugging, and monitoring operations. 4. Summary. In today's lesson, we have gained a preliminary understanding of PLC200 smart programming, including the installation of the programming software, communication setting, and basic operations of the programming interface. I hope you will practice more after class to ensure you are familiar with the software, and try writing some simple programs to lay a solid foundation for your further learning. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.